Hey guys, welcome back to class. Today we're going to be learning how to write equations for circles, and that is lesson 4.1. So you may remember that you actually already learned how to write equations for circles back in geometry. And actually we're going to start out doing some problems very similar to the ones we actually did in geometry, but then we're going to kind of take it to the next level. So you may recall that the general formula or general format for this equation for a circle is, actually we've got to fill in a few things, but it actually is this equation here, x minus h squared plus y minus k squared equals r squared. Now, notice in the drawing here, this circle is graphed in the coordinate plane, and if you look at this, so you got the radius that's drawn, right? And we know we need the radius of the circle to write the equation. So this little segment that I highlighted here is the horizontal segment that kind of creates that right triangle. And so since those points that are listed there have coordinates hk and xk, actually that should say x, yeah, xk, sorry. If we wanted to find the length of that side there, we'd have to subtract the two x coordinates, right? And that's where the x minus h comes from. That's where this part comes from. And then if we wanted to find the length of the vertical segment, this part right here, right, that would be the difference in the y coordinates, okay? And so we've got coordinates x, y, and xk. And so the difference between the y coordinates would be y minus k or k minus y. But in this case, they put the y first, so it's y minus k. And then since we're using Pythagorean's theorem, it's like we would take the two legs here and we would square them, add them together, and then if we took the square root, that would give us the radius. Well, that's actually where the equation for a circle comes from. It comes from Pythagorean's theorem. So to write an equation for a circle, all we would have to know would be the h and the k, which actually are the center of the circle. You can see here, right? That coordinate right there. This coordinate right here is the center of the circle. So that's the key. It's the most important point right there. And we also have to know the length of the radius. So that's the format we're going to write these equations for circles in. And really just the rest of this part of the notes here is really just kind of showing where these lengths of these sides of the triangle that we end up using Pythagorean's theorem with to get that length of the radius. So let's go ahead and give this a try. So if we knew that the circle had a center at -3, 2, and a radius of 4, this would be really, really easy to write the equation for the circle. So it would just be x minus the h plus y minus the k, and squared, both of those, would equal the radius squared. Well, oops, so I actually want to get rid of the k here. So the h, or the x coordinate of the center, is -3. So that would be x minus -3, which would make x plus 3 squared. And then the k is 2, that's the y coordinate of the center. So that would be y minus 2 squared. And then the radius is 4, so that would be 4 squared, or 16. And that's the equation for the circle. And whenever we write that, students always say, well, so now do we have to expand that out? Do we have to use FOIL and all that? No, that actually is the general formula. That is the simplified version. It's kind of like writing an equation for a line in slope-intercept form. That's like the desired format. Well, this is the desired format for a circle because you can just look right at it. You can see the center, which would be the most important point on the circle, right? And you can see the radius just by taking the square root of the other side. So that would tell you how far away from the center all those points are. Let's try another one. So we've got, this is our h and this is our k. So it looks like they're giving us 2 points though. So actually, if we wanted to write the equation for this, the first thing we have to do is find the length of the radius. So we can actually use this formula also to find the length of the radius. So yeah, this time they didn't give us the radius, but we could use it one time and work through and actually find the radius. We can just use one of the points as x, y, and one of them as, so we could say this is x and y, and we could say this is the h and the k, and then we can use all this to find the radius. So step one, we're going to plug these values in. So this would be 2 minus -4, which is 2 plus 4 squared. And then it's the y, which is 5, minus -3, which is plus 3, right, squared, equals the radius squared. So 2 plus 4, that's 6. 6 squared is 36. 5 plus 3 is 8. 8 squared is 64. Add those together and they'll equal the radius squared. So 36 and 64 is 100. So 100 is the radius squared, which means the radius must be 10. So the r is 10. So the radius equals 10. But we really need the radius squared anyway, so really that last step of taking the squared is really unnecessary if we're going to write the equation, because now we know that the radius squared is actually 100. So now we can just go ahead and plug in and use the center. Okay, and I'm going to use the center, which is this one right here. So that would be x minus -4, which is x plus 4 squared, plus y minus -3, which is y plus 3 squared, and that equals the radius squared, which is 100, because the radius is 10, right? And if you want to note that, the radius is 10, but the radius squared is 100, and so the equation would be, oops, right there. There's our, oops, let's try that again. There's our equation for our circle right there. So if they give you the radius, this is super easy. You just plug. It's kind of like with lines when they give you the slope and the y-intercept. You're really just plugging them in. But if they don't give you the radius, then you can use the formula to find the radius. Actually, you can use it to find the radius squared. And then you go back and take the center and the radius and write the equation. So this is a good chance for you to give your try on this. So we're going to have you pause the video and try A and B. And when you've gotten a chance to try both of those, tune back in and we'll check to see how you did. So pause the video now. All right, so thanks for giving those two a try. Your turn. Question A is x minus 1 squared plus y plus 4 squared equals 4. And B, the radius, ended up finding out the radius was 6. So you could tell the two x coordinates were the same. So really it was just the difference between the two y's. The radius was 6, so the equation x plus 2 squared plus y minus 5 squared equals 36. Okay, so of course it's going to get a little bit more tricky and a little more challenging. So let's move on. So the next thing we're going to do is we're going to rewrite an equation of a circle into this is what's called the standard form for a circle. And then we're going to graph the circle. So earlier I mentioned that students always ask when we write equations in that standard form, the first thing they always say is, now do we need to expand those out? Because they have like, x minus 3 squared, let's say. They want to know, do they have to then expand that out? But I mentioned that actually is the preferred format of an equation for a circle, so that you can just directly look at it and see the center, read the equation and see the center, and then take the square root of the other side and get the radius, right? So, but what about if you are given an equation and it's not in that form? So it'd be kind of like if you were given a line that's in, say, standard form, and you wanted to solve it and put it in y equals mx plus b form. You'd have to just rewrite it in that other form, right? Because it's more desirable. Well, we're going to be looking at what's called the expanded form for a circle, and we're going to try to take that and rewrite it so that it's in this standard form, so that we can just see the center and the radius right in it. So this is what expanded form would look like. Okay, so if we have something that looks like that, and we want to put it so that it's in the that standard form, then we're going to have to use that process called completing the square that we learned. And we used that back with quadratics, right? So let's take a look at an example. So in example A, we have x squared plus y squared minus 10x plus 6y plus 30 equals 0. And so you can clearly see this is not in that standard form. So the first thing you would want to do is you want to kind of reorganize it so that you have any terms with x together and any terms with y's together and any constant terms on the other side. So the first thing I'm going to do is just kind of reorder. So I'm going to rewrite so x squared and then minus 10x. And then I've got the, we have plus y squared plus 6y. And then I'm going to swing that 30 over to the other side, making it negative 30. Oops. Actually, I want to leave a little space here. Now, you may wonder why I'm leaving a little space here, but remember we did that when we did the completing the square, and that's actually what we're going to do right here. So what we're trying to do is we're trying to get this to look like x minus something, right? And this to look like y minus something, right? Squared. And then we're trying to get the other side to be the radius squared. So if you look at this x squared minus 10x, if I were to make this a perfect square, just this part right here, a perfect square trinomial, then I could write it in that binomial form, right? Squared binomial form. So what would I have to add here to make this a perfect square? Well, remember how we figured that out. We would take the b, which is negative 10, and we would divide it by 2, which makes negative 5, and square it, which that is 25. So I'm going to go ahead and I'm going to add 25 right here. But since I just added 25, I have to go over here and add 25 to the other side as well to keep it in balance, right? So then we're going to do the same thing with the y's. So the y's, got to figure out, oops, hold on. We got to figure out what we have to add here to make that a perfect square. And whatever we do, we're going to add it to the other side. And so I know that half of 6 is 3. 3 squared is 9. So I'd add 9 here, which means I'm going to add 9 over here, right? And now I can go ahead and write these two perfect square trinomials in square binomial form. So x squared minus 10x plus 25 can be rewritten as x minus 5 squared. And the y squared plus 6y plus 9 can be written as y plus 3 squared. And then if I put all these terms together on the other side, the negative 30, the 25, that makes negative 5, and then add 9, that makes positive 4. Now we've got our equation in standard form. So now what we can do is look at this equation, and we can see that the center must be at 5, negative 3, right? Because it's, if you rewrote this one as plus negative, right? Oops, let's see. Sorry about that. If I rewrote this one as plus negative, this would be minus negative 3, right? Minus negative 3. And so then that's 5, negative 3 for the center. And if I took the square root of this side, that's going to give me the radius. So the radius, oops, let's take that off. So the radius must be 2. So I could go ahead and graph this now just by plotting the point at 5, negative 3, which would be right here. And then I could plot what are called the lattice points. And that means all the points that are directly above, below, or to the right and the left of the center by using that radius. So that radius is 2, so I just go 2 units to the left and the right. I go 2 units above and below. And now I have points that I can use to draw my circle. Now these circles are not going to be perfect when you draw them, so don't worry about it. Don't get a compass out to do that or anything. It's just do your best to try to draw something that includes all those points. So that's the process. We basically group the x's and all the x terms together, all the y's termed together, and all the constant terms on the other side, and then do the completing the square process. so that we can take each one of the parts and create a square binomial. And then once we know the center and the radius, we can easily graph it. So let's take a look at another one. Okay, so this is going to start to get a little harder, right? So now we can look at what we have here. We've got a 4x squared plus 4y squared plus 8x minus 16y plus 11 equals blank. Okay, well, so let's go ahead. It's supposed to say equals 0 is what it's really supposed to say over here, but there's just a 0 there. But we're going to go ahead and take the 11 to the other side. So that's going to be negative 11. We're going to group the x's and the y's together, or x's and the x's together, excuse me. So that's 4x squared plus 8x, and then plus 4y squared minus 16y. Now the reason why I didn't leave any spaces this time is because I'm going to have to do a little work before I can do the completing the square process. So I'm going to have to rewrite it anyway. So if you look at these terms here, every single one of these terms is divisible by 4. Now the negative 11 isn't, so we're going to hold off on doing that, but we could factor out a 4 out of each one of these things. So I could take a 4 out of the 4x squared and the 8x, and that would make x squared plus 2x. And then I'm going to leave my spot here now to complete my square. And then out of the next part, I could take a 4 out as well. So that leaves me with y squared minus 4y. And then I'm going to leave a spot there to complete the square. And then on this side, I have negative 11. So then what I'm going to do is figure out what I have to do to add or to complete the square, right? So I'm going to take half of the middle term, 2, which is 1, and square it, which is 1. So what I really did add, though, to this side is actually a 4, right? Because 4 times 1 is 4. So on the other side, actually, let me change this to red. So I added 1, but what I'm really going to add over here is I'm going to add 4, because 4 times 1 is 4. And then for the y's, I'm going to take half of negative 4, which is negative 2, and square that, which is 4. But what I really added here was 4 times 4, which is 16. So I'm going to add 16 over here. And I'm going to clean that all up. So, see, I'm going to write these in square binomial form. So that's 4 times x plus 1 squared, right? Plus 4 times y minus 2 squared equals, and then when I add all these constant terms together, I have positive 9. So now the standard form does not have 4's in front of those quantities, the x minus h squared and the y minus k squared. So my last thing I'm going to do here is I'm going to divide that off. So I'm going to divide each term by 4. That by 4, that by 4, this by 4. And that leaves me with x plus 1 squared plus y minus 2 squared equals 9/4. So what's the center? Well, the center must be negative 1, because that means this part right here must be minus negative 1, right? And 2 for the y. And then what's the radius? Well, the radius is the square root of 9/4, which is 3/2. So it's not a great radius, but it's not terrible either. They're both perfect squares, the 9 and the 4, so it was really easy to figure out that radius. So now all I have to do is plot that point. So that's negative 1, positive 2. So that would be right here for the center. And then I have to go 1.5 units above, below, to the right and to the left. So 1.5 above puts me right there. 1.5 below puts me right here. 1.5 to the right puts me here. And 1.5 to the left puts me here. And there's my little tiny circle. So basically, this only is going to work if we can divide the exact same thing out of the x terms as we can out of the y terms. So that's always a question people ask. Well, what if we can't? What if you can't divide the same thing out? Well, then we can't do this then. So it is really dependent on that. But So we can even go, to something as complicated as this, and still by using our completing the square method, we can rewrite it into the standard form. So I know it seems like this should be time for a you try question, but I think this is probably a good time to try some more together. Maybe we'll hold off and just continue with doing these together, and we'll maybe have a you try in class. So again, how it works is step 1, reorganize it. So you have your x terms together and your y terms together. So this one's a pretty easy one because we don't have any coefficients on the x squared and the y squared. So that would be x squared plus 4x, and then y squared, plus 6y. So I'm leaving my spots to add these in because I'm going to go ahead and complete the square here in a second. Now I swing the 4 to the other side, that makes that negative 4. So now I'm going to look at what would make this into a perfect square. It would be half of the 4, which is 2, and then square it, which is 4. So I add 4 there, I add 4 to here. Then with the, and I gotta see if I can sneak a little plus sign in there. There's a plus. I'll rewrite that real quick. Put a plus, and then a y squared there. Okay. So then I'm going to add half of 6 squared, so that would be 9 to make that a perfect square, right? So I'm going to add 9 over here. And now I'm going to rewrite it into square binomial form. So that makes this x plus 2 squared. And remember, the sign always comes from the middle term, right? So that's why we knew that was a plus. And then plus, and then the same thing here, so that's y plus 3 squared. Put all my constant terms together, and that leaves me with 9. That means the center is at -2, -3, and the radius is the square root of 9, which is 3. So -2, -3, the center is right there, and then just go 3 above, below, right, and left. So those 4 lattice points, 1, 3 below, 3, 1, 2, 3 to the left, 1, 2, 3 to above it, and then I just try to do my best to make a nice little circle. Yeah, that's a terrible one. And they usually get worse the more I try. So just do your best. And if I try to do one half of the circle and then the other, it usually looks like a football. So don't judge yourself too harshly if they're not perfect. All right, let's try one more complicated one. So the first thing is, we can tell right away we can do this process of dividing out that number because they have both the x squared and the y squared both have 9 as the coefficient. So we're going to kind of reorganize this, and then we can factor out that 9 so that we have we have something that we can use our completing the square process on. So we have 9x squared, and then put the x term with that, which is minus 54x. And then we have the plus 9y squared and the minus 72y. And then, of course, we're going to swing that 209 to the other side, making it the opposite sign. So it's now negative 209. So we're going to factor out the 9, and that leaves us with x squared and then minus 6x. Right? And we'll figure out what we're going to add here. And then if we factor the 9 out of the y's, that's y squared minus 8y, and then we'll figure out what we're going to add here, and then whatever we do, we're going to add it to the other side as well, right? Add it to the negative 209. So half of negative 6 is 3, 3 squared is 9, so what I really added, though, is 81, right? 9 times 9 is 81, so I really added 81 over here. And then I'm going to take half of the middle term for the y's, which is negative 8. So half of that is negative 4. Square that is 16. But then what I really added is 9 times 16. And that's 144. And now when I clean that all up, and I've got 9 times, this is x minus 3 squared. So I take the square root of the x squared and the square root of the 9. The sign comes from the middle. And then the 9 times y minus 4 squared. And then put all these together. When I add them all together, I actually get positive 16. So now I've got to just divide the 9 off. So everything gets divided by 9. This divides by 9. This divides by 9. This divides by 9. And then identify the center and the radius. So the center now, since these things are going to get canceled off, right? Basically, these are gone now. These are gone now. And my center is 3, 4. And my radius is the square root of 16/9, which is 4/3. And that's not going to be great for graphing. That's 1 1/3. We're definitely going to have to estimate that. And on this tiny little graph, this is going to be the tiniest little circle. It's only 1 1/3 for radius. But so the center's at 3, 4. So go over 3 and up 4. 1, 2, 3, 4. And then I just need to go 1 1/3 to the right, which is right about here. 1 1/3 to the left, which is right about here. 1 1/3 down. And 1 1/3 above. And draw that tiny little circle. Actually, maybe the tiny circles are easier to draw. Obviously, I didn't get right there on that one point, but hey, good enough. With a little bit of practice, these will start to just come really quickly too. Just like when we started with completing the square, when we had like a leading coefficient to divide off. The first couple were a little tricky, but then things just start to kind of become routine. So now we're going to wrap up the lesson by looking at some real-world problems that we could solve using a circle. So a circle in a coordinate plane divides the plane into 2 regions. Points inside the circle and, of course, points outside the circle. Points inside the circle satisfy the inequality x minus h squared plus y minus k squared is less than r squared, right? So if they're less than r squared, they're less than the radius squared away from, or then that means that they're closer into the center, right? While points outside would satisfy the inequality x minus h squared plus y minus k squared is greater than r squared. So in other words, they're more than the length of the radius away from the center, so they would be outside the circle. So example 3 says to write an inequality representing the given situation and draw a circle to solve the problem. The table lists the location of the homes of 5 friends along with the location of their favorite pizza restaurant and the school that they attend. The friends are deciding where to have a pizza party based on the fact that the restaurant offers free delivery to locations within a 3-mile radius of the restaurant. At which homes should the friends hold their pizza party to get free delivery? So first of all, where is the pizza restaurant? Because that's, where we're going to have that 3-mile radius that it has to be within. So that's at negative 1, 1. So let's see, negative 1, 1 would be right here. And we know that it's a 3-mile radius, so we could draw that circle by doing the lattice point. So we go 3 up, 3 down, 3 right, and 3 left. So essentially we're talking about points that would lie in this circle. And again, that's not a perfect circle, so I'm not going to really rely on that as a perfect circle. So if I were to then write the equation for that, so we're looking for our points that satisfy this inequality. X plus 1 squared, right? We're using this as the center, right? And plus y minus 1 squared. And we want them to be less than or equal to 9, which is the radius squared. And if one way we could test this is to try these points, plug them in, and see if they satisfy this. And that's the first thing. So we could do that. So we could take Alonzo's home. We could put the 3 in here. right? We could put the 2 in here, and we could see if it's less than 9. So that would be 3 plus 1, which is 4, squared, which is 16. And then, so clearly that one's going to be too far out because it's already 16. So anything we add here, it's going to be, you make it even bigger than, that much more bigger than 9, right? So I can already tell that, because then this would be 2 minus 1, which is 1. 1 squared is 1, so that's 1. That would be 17. So that one's definitely not. Can't be their house, right? Okay. Barbara's home, you could put the 2 in. So if I put instead a 2 in here and the 4 in there, so 2 plus 1 is 3. 3 squared is 9. Okay, so that's 9, and then 4 minus 1 is 3, that's 9. 9 plus 9, clearly that's bigger than 9. So that one can't be their house. Constants, negative 2, plug negative 2 in here, and plug 3 in here. So negative 2 plus 1 is negative 1. 1 negative 1 squared is 1. So that would make this, oops, let me just make this 1. Put these up top. So negative 2 in here and 3 in there, right? So that would be 1. Negative 1 squared is 1, right? And 3 minus 1 is 2. 2 squared is 4. So this one would work. Constance is home. She's a contender for the party, right? The pizza party. We're going to put Constance. So I'll list her as C. They're all, you can obviously see they're A, B, C, D, E, and then school, right? And so, let's see. What did the school have to do with things? Along with the location of their favorite pizza restaurant and the school they attend. Huh. I don't really know what the school that they attend that has anything to do with anything. Oh, they're going to ask that in the next part of the question. Yeah, that doesn't make any sense. So Dion, let's see. So Dion, let me erase these. This is 0, negative 1. So I plug 0 in here for x and negative 1 in for y. So that's 0 plus 1. 1 squared is 1. And then negative 1 minus 1, that's negative 2. Negative 2 squared is 4. There's another one. So it could be Dion. So Dion's also in the running. And then Eli. So let's see. Eli, got to plug his numbers in. So if I plug 1 in for x and plug negative 4 in for y, 1 plus 1 is 2. 2 squared is 4. And then negative 4 minus 1 is negative 5. Negative 5 squared is 25. That's definitely out. So you could think about if you looked at like graphing those points instead. So you could have also done that. This is official though. So just see, so Constance and Dion are the people where, the party would have to be, right? So, but think about plotting some of these points. So Alonzo's, his was at, house was at 3, 2. Right, so over 3 and up 2 was right there. Yep, that was just out of the circle. Barbara was at 2, 4. So let's see, over 2, up 4, 1, 2, 3, 4, up here, right? Still out of the zone of delivery. Negative 2, 3. So negative 2, 1, 2, 3. Yep, that was Constance. That's right there. Right there, inside there. And then 0, negative 1, so that was right here, Dion. Dion's within the perimeter. And then Eli, what was Eli's? Was it 1, negative 4? Yeah, it was 1, negative 4, over a 1, down 4, 1, 2, 3, 4. That one was significantly farther out, so E was way out here. A was at 3, 2, that was A, and that was B. So clearly C and D are the only ones that could host, so that would be Constance and Dion. So part B says, in order for a student to ride the bus to school, the student must live more than 2 miles from the school. Which of the 5 friends are eligible to ride? Okay, so they can only be 2 miles from school. So basically what they're saying is the center, or the school, from where the school is, they can only be 2 miles away. So let's see, now let's plot the school and figure out what that circle looks like. I'm going to use a different color on that, like a green one, right? So the center for the school is at 1, negative 2, over 1, down 2, right? Oops, right about there. And then the radius is 2 mile radius. So up 2, right 2, down 2, which is right there, and left 2, 1, 2, right there. And the circle, so it looks like Dion and Eli are the only ones. So the points D for Dion and E for Eli. So only Eli and Dion can ride the bus. Oh, actually, I just lied to you. No, Eli and Dion cannot ride the bus. They're within the 2 mile radius. That doesn't make any sense. You're probably thinking, Mrs. Brunk, what are you doing? So yes, Eli and Dion are in the circle there, right? So they are either exactly 2 miles away, which is what Eli is, or within 2 miles, which is what Dion is. So the rest of the people, C and B and A. So that's Alonzo, Barbara, and Dion. Constance. Boy, I just want Dion to ride the bus. B-A-R-A, and Constance can ride the bus. Because they're outside of that circle, which it means they live further from school and are eligible to ride the bus. Okay, so I think, probably the most, I guess, mathematical and technical way and the most correct way to test these is to write the inequality and substitute the values in. And make sure that they're actually below that certain value or above the certain value, whatever. But certainly graphing, if you're careful, can at least give you an idea, and then you can test the points that you're unsure of if you're kind of right on the border there. So let's try one more. Write an inequality representing the given situation and draw a circle to solve the problem. Sasha delivers newspapers to subscribers that live within a 4-block radius of her home. Sasha's house is located at point 0, 1. So this is Sasha right here. And points A, B, C, D, and E represent the houses of some of the subscribers to the newspaper. Which house does Sasha deliver newspapers to? So she delivers within a 4-block radius. So that means if you want to check out the inequality, it would look like this. It would be x minus 0, which is really just x squared. That's what happens if one of the coordinates of the center is 0, then it's just either x squared or y squared. And then plus y plus 1 squared. And you want it to be within, so less than 4 squared, which is 16 blocks. So graphing it would look like this. 1, 2, 3, 4. And then 1, 2, 3, 4 down here. 1, 2, 3, 4, and then 1, 2, 3, 4 to the left. And again, how accurate you are with your circle might, if there's some points that seem to be on the border, you might want to test them. Oops, like that one. This is going to be close. And we want ones that are within that circle. Now, there's clearly, even though the circle's not a great circle, the ones that are outside are A and C, so they cannot deliver to A and C, so just B, D, and E. A and C are out. So if we actually took those coordinates, figured out what they were, substituted them in, we would, could verify for sure. But certainly the graph is not off enough where these points are not close enough to the circle to really warrant. I mean, maybe C. So I think I'll test out C just to be safe. So let's see. C is at -2, 1, 2, 3. So -2, 3. Let's test it out. So plug -2 in for x and square that. That makes 4. Plug 3 in. So that's 3 plus 1 is 4. 4 squared is 16. So that's 20, which is definitely not less than 16. So yeah, that C's out. And then A is at 1, 2, 3, 3. So if I instead tried 3, 3, this one's at 3, 3. Now we're plugging in 3 here and squaring it, and plugging in 3 here and squaring it. So put 3 in there, 3 in there. So that's 3 squared, which is 9, and then 4 squared, which is 16. That's 25. That's definitely outside of the region for delivery. So there's lots of real life situations like that, like, these right here are really good examples of where we could apply the equation for a circle to solve some problems. So that does it for today's class. Thanks for coming to class.